Hello everyone. Our topic that we will discuss today is graduated cylinder measurement reading.
In this video, I'm going to talk about graduated cylinder. It is an apparatus which is used to measure liquid volume. It is usually made of glass, borosilicate, or plastic. Its sizes ranges from 100 ml, 250 ml, 500 ml, 1000 ml, and 4 liters. Its accuracy, since graduated cylinders come in different sizes, they also measure with different degrees of accuracy. They must be read carefully to ensure accuracy no matter what material is used. Graduated cylinders are generally more accurate and precise than laboratory flasks and beakers, but they should not be used to perform volumetric analysis. Volumetric glassware, on the other hand, such as a volumetric flask, volumetric pipette, should be used as it is even more accurate and precise.
Gradation. The term graduated comes from the gradation or measurement marks on the cylinder. The graduated cylinder will have a series of lines to show the measurement intervals. Some lines will be marked with numbers, while intermediate marks will not be numbered. Smaller graduated cylinders usually have narrower measurements intervals, so they measure with greater accuracy. As a scientific instrument, the graduated cylinders uses the metric system rather than the US standard system, so measurements are in millimeters instead of ounces. Milliliters abbreviated as M capital L or small letter ml convert to cubic centimeters, written as cc or cm3. Therefore, 20 milliliter or 20 ml of a measured liquid has a volume of 20 cubic centimeters.
Measurement intervals. Count the number of smaller divisions between marked intervals. For example, suppose the marked intervals are 1 ml, 2 ml, and so on. And there are 5 smaller divisions counted from one numbered line to the next. In this case, the measurement interval marked by each line equals the number interval divided by 5, the count from one interval line to next, or 1/5 equals 0.2 ml. So, the sample graduated cylinder measures accurately to 0.2 ml. Reasonable estimation can be made if the measured liquid lies between the marked intervals, but this estimated reading will be less accurate.
How to find meniscus? All liquids have cohesion or attraction between their molecules. This cohesion holds the surface of the liquid in place, but molecules in contact adhere to that wall, resulting in a curved surface. This curved surface is called the meniscus. The curve of the meniscus depends on the liquid. Water and mercury have two of the most extreme curves because of their strong cohesion. Isopropyl alcohol, on the other hand, has a very flat meniscus. How to read meniscus? To correctly read a graduated cylinder, the surface at the center of the meniscus must be the one to be read, not the top of the ring of liquid clinging to the wall of the graduated cylinder. For most liquids, this center will be the lowest point of the meniscus. For very few liquids, like mercury, the center of the meniscus will be the highest point of the liquid. To properly read the meniscus, your line of sight must be level with the center of the curve of the meniscus.
Once the measurement interval has been determined and the meniscus evaluated, reading a graduated cylinder is a matter of attention to details. Looking straight and the level at the center of the meniscus with the number line below the meniscus, and the incremental measurement up to the last mark below the meniscus. If the center of the meniscus is not aligned with a pre-marked gradation, estimate the amount of additional liquid above the line. For example, suppose the amount of liquid measured in the graduated cylinder lies about 1 1/3 of the way between the third and fourth intervals between the 16 70 millimeter marks. There are counting up from 16 ml mark, 10 intermediate marks, dividing the interval 70 minus 60 is equal to 10. Why the number of the increments 10? Show that each intermediate mark equals 1 millimeter because 10 all over 10 is equal to 1 ml. Adding the measurement therefore gives 60 ml plus 3 ml plus approximately 1/3 ml. 60 plus 3 is equal to 63.8 ml liquid in graduated cylinder.
Things to remember when using graduated cylinder. Number 1. Select graduated cylinder with markings that will not be obscured by the substance. Number 2. Always select graduated cylinder made from a material appropriate for the substance being measured. Number 3. Select the appropriate size of graduated cylinder. Number 4. Determine the value of the graduations on the cylinder. Number 5. Read the graduated cylinder. And lastly, clean the cylinder after use.